Hey, this is Patrick, and today we're gonna put together this Solex 481 carburetor that we took apart in our last video, one of our other last videos. So if you've seen the other video, you discovered that as we were taking it apart, we've learned a few things. So originally it was a so-called rebuilt carburetor. That means a carburetor I rebuilt some time ago, and like some time ago being a few years ago. And quite frankly, I had no clue what whether I rebuilt it correctly or not. As we're taking it apart, we discovered a few things. We discovered that the parts of the carburetor are well warped somehow, to some degree, but that this part right here, which is the top part of middle section, which often gets warped, the fact that the bottom part of the middle section, which was not warped, which barely ever gets warped in all the carburetors, and that the bottom part of the top section is warped as well. And so in other words, that's a very common thing. Bottom part of the top section, top part of the middle section, and the bottom part doesn't get warped. Maybe I mentioned in that video or not, but I do have a bunch of wonderful pieces of some other carburetors. That means, and then the other carburetors are kind of beautifully straight, like we're talking straight, like a shooting arrow, I guess. I don't know, would be a good saying. Except there, as I started kind of creating that video, I don't think I released that video because in essence I found lots of other issues. Now, incidentally, the issues were not related to the warpage per se, because as I said, there was no warpage, but rather something else. This is part of that rebuild part, and I guess I'm gonna talk to you about it, why I chose not to use those perfectly unwarped smooth pieces to do our rebuild, and actually go ahead and try to attempt to salvage our current carburetor that we started out with. So I guess let me just take this part off, since I already started putting it together in some other video. The reason while that rebuild parts were actually turned out to be less than ideal is for a number of reasons. There are simply so Solex 481 carburetors, they looked very similar on the surface, but over the years there were lots of little changes that between the body parts. Let's see. So much so, I mean, again, all the parts, they have like a little number here, the bottom part, the middle part that has it here, and the top part has some kind of number. Let me see where I can find it. It's right here, and you will notice that they all over the place. Well, so this beautiful part that's smooth here has a bunch of issues that we will have to deal with. The issue number one is that it has an anti-choke, T and choke. So that's something we'll have to figure out how to kind of overcome it, get rid of it, and so on, to simplify things. Then another important issue that we were dealing with, because of that, certain gaskets that we had would or would not work properly. And then let me just pick out the other part, the top part. So here was the top part from that, and again, oh my god, this is a perfect straight edge, like horizon perfect. So you would think like, oh, fantastic, again, wonderful, everything's working beautifully. Few issues. First of all, because it has that T and choke, so we'll have to figure out how to create a gasket, custom gasket between those two parts, so that if we're going to get rid of this T and choke, because quite frankly, I don't want to deal with T and choke. This is one of those things that I decided that German engineers overcomplicated on this carburetor. I don't want to deal with it. It overcomplicates the Walmart's characteristics. But because of that, there are other complications as well. So there are openings right here, this and here, and that our original carburetor has the same openings, but they're much smaller. So this carburetor requires this little piston set, something like this. I don't see if you can see it. Hold on. Something like this. So what it is, it's seemingly simple device. So basically, there's a spring at the bottom of it, and then when the vacuum overcomes the spring, and then this thing kind of pushes up and down based on the vacuum, and by pushing up and down, it creates a smaller amount of air entering our mixing tubes, or a larger amount of air. Now, because our original the one we're rebuilding carburetor, this one right here, didn't have it. So in other words, it has the openings of much smaller. So that means it doesn't use this piston. So because of that, we will have to figure out a few things. So the vacuum that feeds this piston is the very vacuum that comes from the bottom of the carburetor. I think that might be this hole. And that means us trying to create a gasket to get rid of tea and choke would not be so easy, because those are kind of like the holes overlap. So all of a sudden, I had to figure out, okay, can I reroute this vacuum signal from somewhere else, or figure out how to create a gasket that gets rid of the tea and choke, and so on. On top of that, we had here, and this our so-called perfect body part of the carburetor. We had a fuel bowl vent that I would have to block somehow, because I don't want to. I basically want to rebuild the carburetor to create as simple a carburetor as possible. So it's only the basic components, and fuel bowl vent that either it's electric or vacuum control is not something that I want to deal with, play with, and whatnot. I could, because I have spare parts, but at the same time, this is yet another, the more components you have with any system, the more failure parts you have. So as I kept on doing those things, I started discovering that maybe this is not the best idea to and then on top of that, our jets. So in other words, this is getting a bit messy. Let's see, let me just move this to the side, and then this for a moment as well. Okay, so let's see. So that's the bottom of the carburetor. This is the part, the original part. This is the one with the straight, smooth surface. With this one, the pipes for the transitions are longer than in this one, and the reason for this is that they wanted to limit the amount of fuel that you have access to for the transition. So with the original one, you had separate chambers, later on as well, but here with the so-called is it a new one? I'm not sure it's a new one. It might be simply basically because this is Solex. This is the Pierburg. I'm not sure if I pronounce this correctly. But anyway, so those pipes here are much shorter, so that would create different characteristics for driving. Again, not necessarily end of the world, but then you have what's called, as you can see, this differences here. So those are where our main jets for our carburetor are. So this one doesn't have any right now. Here you have something, and then you have those screws right here, which are basically blocking ports, and here you don't have any, which means if you flip it around, which means that our jets, like air jets, are a bit different. So here you have a smaller. Let me see, maybe I should get like here, right here, smaller jets, and here have a much bigger jets. So that means that two different carburetors that kind of create their emulsions a bit differently. So in that sense, I'm reverse engineering a carburetor here for no apparent reason. So because of that, I was like, what, screw it. Let me go and simplify things and kind of like rebuild our original carburetor in the best possible way. Now, kind of important issue. If I simply took random parts from a carburetor bin, let's say our crooked top, and let's say our perfect bottom, and let's say I merge them together, then you will discover that there is quite a lot of light coming through through this space. Now, because this is the part from a different carburetor, this is from a different carburetor. However, if I take the parts from our original carburetor and merge it with our so-called crooked part, then you will discover that there's actually very little space here. So, in other words, when the carburetor distorts, it distorts in such a way that there's a possibility. So even though if I put a straight edge to it, it's totally crooked. But if it distorted together, so it was this part, bottom part distorted with the top part, which often is the case, then because the screw that distorts this carburetor goes actually to the bottom part, so it actually pulls up from the bottom. And then, so as long as the bottom part is straight, which it is with this one, maybe you can't see, but I can tell it. So that means bottom part and the middle part will merge beautifully, and middle part with the top part will merge more or less beautifully if, and here's the kicker that complicates this thing for you watching at home, if you use the custom gasket. So let's talk a little bit about gaskets for a moment. This is let me see if you can see the difference. Alright, so one of those gaskets, the thinner one, is the one that comes with your rebuild kit. Let me just put it like this. So it's the thicker one is a custom gasket that I cut out myself, which obviously takes half an hour to do, something you might not want to do. And the thicker gasket, just out of curiosity, is at least if not more, twice as thick as this one. So remember, it's cellulose, which means basically paper, and that means this has way more material than my custom gasket to compress. So if I do it in a clever way, I can hope that I'm gonna see all the spaces in between. So you know what? If you only simply had access to your it was called a store-bought gasket, the thin one, then I would say, you know what? You're kind of risking a lot by rebuilding this kind of warped carburetor. But because I have this thicker gasket, then I have a lot material to play with. Just out of curiosity, let me see how those gaskets compare. Whether there's anything that we're missing. All right, so we don't have the registration. Why is it we don't? Incidentally, we don't here. Huh? There's no registration. A hole here. See, this middle hole is missing in my custom gasket because we don't need that. Was called that's for the vacuum that feeds this element right here, which we don't need to deal with. Then what else is missing is let me see what do we have here. This right here, and that opening missing from my custom gasket because this is an opening for the tube, the fuel tube that for TN choke, that, as you can see, although that stuff is missing in my custom gasket. And then also we have this, that's I think for the vacuum, if I'm not mistaken. Hold on. Hold on. Yeah, it's some kind of vacuum signal. I'm just trying to see for what. No, maybe it's missing. It's incorrect on this specific one. So that's kind of curious. It's for some kind of vacuum signal, but for what? Well, either way. So there's an extra something that I clearly didn't need when I was making this gasket, cutting it myself. So anyway, well, here's the thing. Like, you're clearly watching a rebuild video of a carburetor, so maybe you do have an interest on how to kind of rebuild your carburetor that probably might be crooked right now. So maybe you do want to spend considerable amount of time to create your own custom gasket from a much thicker material. Incidentally, including this one as well, that does have also a thick gasket on the top and the bottom, this plastic spacer from the bottom up and middle part. So anyway, so that's our situation. So we have a great gasket that we can potentially merge the parts in such a way that it's gonna actually work very well. All right, so let's start working. Let's make sure that we have the right parts. So this is our now this is our quality top. This is our crooked top. As you can see, the fuel ball vent is already closed off. Let's see, those air jets, I need to double check what they are. Let's see, now we have to put those middle jets. So the middle, our main jets. So this is, I'm trying to turn this carburetor into a 1973 American version. So the American version based on this paper. So this is our thing. So our main jet's supposed to be the 100 number, and I think I put them into, double check what they are. Of course, now I'm supposed to, let's see if I can take a picture of. All right, let's see. Okay. I cannot tell. This is not sharp enough. I should. Oh, come on. I'm pretty sure they're 100 because I checked the last time. But here I'm trying to tell you the procedure how a so-called old man is trying. I'm not that old, but old enough to need. Yeah, it's Solex. It's a Solex, and it says 100 here. You might never be able to see it, but now that means you have to use the trust. All right, so I need to basically take those jets and put them right here. So let's do it right now. They're very loose, so that means I never even bother screwing them in. All right, it's not the best. My tools are not fantastic today. Okay. Okay. So we have 100 jets right here. Based on this literature, idle air jets should be 110. Idle air jets are those little guys right here. So maybe we should take a picture to make sure that indeed it's so dirty. I can barely tell. Let me see if I can take this picture. Maybe some light so that. Okay, yeah, you can better say, but it says Solex 1 here and it says 110 on the other thing. So yeah, so those are 110 jets. If you're curious, let me just pull them out so that you can see what they look like. They're super tiny. There you go. They're that small. Yeah. So what happens is, if you're curious, so you have basically a fuel entering through our main jets for our fuel ball and going into this other tube, and rather this other tube allows some air, very obviously precisely measured amount of air, going in that as well, so that within those long tubes that you saw just moments ago, and then I'm going to show you in a second after I somehow managed to put this. Ugh, you stubborn. So when the air, a precise amount of air and fuel mixes, you create this thing called emulsion, and then you send that emulsion into your passages so that it can be sucked into the engine chamber via either idle opening or your main opening. Okay, good. Okay, good. So we're using our reference thing. So our main jet is a 100. So if you're curious, and if you can see for later cars, 1974 California, your main jet should be to 112.5, and then in the later on in the 75, 76, in 75 it should be 100, in 76 should be 105, and then idle air jet for your 73, 74 should be 110. In California should be 100, and idle jet for 75, 76 should be 102.5. What else? Needle jets, jet needle. So in our second stage for 73, 74 should be A4. For California 74 should be A5, and A7 for 75, 76. So needle jets are those guys right here. Yeah. So I'm just gonna kind of show you how to get to them so that you can see what's going on. And then, so I'm basically pulling this circlip. Okay, removing this low washer, pulling this guy out on this side, and then this guy right here, and then you have this plunger, yeah, and then the numbers of your needle air needles, those are your air needles, are right here on the top. So this one 84, and this one is 84 as well. Do I have some sample ones from let me see, from other years? Let me see, so some other years. Read it. In essence, what it is, it's just a small love differences between the taper of the bottom part. All right, so that means for this specific carburetor, we have a correct what's called idle air jets. No, idle jet, what am I saying? Jet needles for the second stage. So let's put this in. Okay, make sure that it operates nice and smooth. And then you put this guy in. There's a little, and then this part right here, this round thing, wraps, and that there is a plastic cam that controls those valves. So you shove it in there, and the idea is, after you put this guy in, so the idea is when those flaps move, as you can see, those things move as well. So you see, yeah. So you know what's movement of this and this. In the manual, there is a proper way of setting this height as well. Since we are doing a rebuild, you know what, let me pause it for a second, and then I'm gonna find the page from the manual to show you how it's done. Hold on. So I'm back so that we can look at the specific how to set the dimensions. So this is a cross section. right here of this jet needle. And then what do they want from us? So what they want from us is on a 110 engine, they want the dimension B to be dimension A plus more or less 3 something millimeters. So what is dimension A? Dimension A is when you measure the top of this needle resting inside without this level right here. So let's just really quickly pull this out for a moment. All right. Okay. So there you go. This falls slightly. We take some kind of measuring device. Here we have like some fancy brass something. All right. Okay. Well, maybe we should find a different. Oh. Hold on. Is there a way for us? This one is not good. Come on, we need to figure out. None of those things are working so well for us, huh? Alright, so dimension B should be our dimension A, which we cannot tell because damn it. Anyway, what I'm trying to measure right now is, let's see if you can see here, the bottom of here to the top of this, and I write it down. Right now I'm just gonna do it super roughly. So let's call it, it's around, nothing is helping to us today. Well, it's around 6 to 7 millimeters. So right now from here to here we have 7 millimeter plus the proverbial 3.3, so I should be at around 10 millimeters. So in other words, when I put this element in, this bottom part to the top should be around 10 millimeter. So let's just do it right now. Okay, and it's way more than 10 millimeter, which means either I'm doing something fundamentally wrong, which I am because I don't have the pin in. Let's put the pin in. Okay. So now let's measure dimension from here to here. Yeah, I'm like at 10 point something millimeter, so close enough. So yeah, and so what would happen if this dimension was too big? I would have to basically take this part and put a screwdriver here, or like hammer this a little bit in, as they show you actually in those two drawings. So here you have the screwdriver creating bigger opening in this element, and here you have the making it smaller. So I'm well, close. I would say close enough. Not perfect, but close enough for the purposes of what we're trying to do. So in that sense, as far as we're concerned, those things are set properly. So let's just put the washer. Let's just put this this clip. All right, so we're good to go. All right, so we're done with this. All right. So we already said the this, that, and the other. I think we can start putting this carburetor together, right? All right, so let's take our middle part right here. So what's involved in putting the middle part is creating the what's called adding the float. So I obviously have a bunch of different floats. I don't even remember which one is the one I said correctly, but doesn't matter. Let's just use the random one, and then based on this, all of this is just, I have this valve at the bottom hanging by the low spring, then this bolt right here, and then it goes into this opening. Okay, then we have the spring right here on the top, and then almost there. And then I measure. You see this divot right here? If I put the straight edge, this divot should be basically flat. Now, right now I can tell this is a bit lower than it has to be. So in that case, let me just double check this one so we don't have to even operate with this. Out of curiosity, maybe it was this float that was the correct one. All right. Yeah, more or less. Yeah, it's close enough. It's supposed to be within, like, I think 2 millimeters up and down. So right now I think it's 1 millimeter higher than it has to be. If I have to bend it, see those tabs right here? So you would just bend it just a little bit. Since I was slightly too high, I would just bend it just maybe too much. Well, let's see. Remember, those are carburetors. They have to operate on more or less level. I remember when I was starting out, I would be like, oh, it has to be super precise, like a computer precision. No, it doesn't. Okay, close enough. I would say close enough. Close enough. Cool. All right, so now our float is set correctly. And then that's that. Then we can take our nice gasket, covered with grease, set it correctly. Those are for the this little I don't know what you would call it, protrusions. It has it's for the squirt of the accelerating pump. This little divot, and it's ready to take the top part on it. So this is all that's going in. Make sure to line up all the openings and all the holes, which is not so easy to do when I have a camera above me. All right, so now you want to take some of the longer bolts. Which one is the longest one? I don't think it's, well, either way. Let's start, at least do the middle part. So those bolts are the ones that you want to crush the most, because remember, the idea is to crush this gasket, this paper gasket, so that there's a good seal between the top and bottom part. So right now, I'm basically, by tightening those quite significantly, I'm crushing the paper gasket in here with the assumption that that whatever sealing surfaces, you know, over here crush the most, and then I can deal with the other surfaces. So this I'm gonna attach much more in a looser way. Again, loose is relative, but it definitely, those are the ones I care about the most, and here, right here as well, because that's where the sealing surfaces need to really to seal. Okay, and now we're taking those guys. One of those guys was a shorter bolt. Which one is it? No. No. All right, so all those 4 bolts are nice and tight, because those are the ones that go around the fuel bowl where the proper fuel thing has to take, a proper seal has to happen. All right, let's see, what should we do next? Maybe what we should do is attach the choke housing. So let's see, we need this low plastic washer. Okay, then we need this guy right here. Okay, then we need to put, let's see, maybe I should disassemble this so you can see what's happening inside. Okay, so this is like basically something like this with a tab right here, and this tab right here catches this tab right here. So this goes like this. This goes like inside there. Now before we do that, we have to put this little linkage that connects our choke to this this element right here, like this. See? Okay, so now to do that, it's one of those things that's easier said than done. Okay, now I need to look down here and basically put this thing. Alright, how the hell do I do it with let's see. On one hand, I want you to see it. On the other hand, it's so dark down there that you might discover that's very hard to see. Capture it. Yes, I did. Great. All right. Now I have to attach this screw right here. I think it's one of those guys. Correct? No, it's the one with this one right here. Now this goes here. I need to attach those 2 tabs, or rather this, whatever the names are, this metal piece to this metal piece. Okay. And then there is a low fastener circlip going in here. Okay. Alright, so now if you notice, by moving this thing goes up. Or rather, this counterweight, when it's loose, by the physics of the being a counterweight, it opens this flap right here. Yeah, and likewise this part right here, you see what it does. So if there is a spring right here holding onto this thing, so because there's a spring and this bimetal spring, and it stays up, and this thing is trying to work against the spring, and that spring, as it warms up, it becomes loose and loose and loose, and that becomes looser and looser and looser and looser and looser. It allows the choke to open up. Yeah, pretty clever. And then you have this piston right here. That's basically choke pull-off. There's a whole video about it, what it does. Anyway, so now okay, so by the specs, when you're holding this tab, as far as possible, there should be around 1 millimeter space right here between this aluminum housing and this tab right here. Yeah, and there is more or less around 1 millimeter. Around with choke is good enough, because the choke is never perfect. All right, so now I can attach this this choke housing, making sure that this spring tab right here catches onto this thing. Okay, attach the now, if you notice, there is a mark right here and a mark on the choke housing right here. More or less line it up, more or less. Now, if you line it up, you discover is that over the years that spring became a bit loose. So this distance right here is actually lesser than or rather more than 1 millimeter. Right now it's around 2 millimeter. So don't be afraid to just kind of go on a slide in this direction. The farther you go, the what's called. Let me see down the things then. Yeah, don't make it too far, but don't make it too loose. This is too loose. Yeah, load now, you know, with the spring, just slightly past the marking is okay. So now because there's a spring in here, you see if I pull on it, because this housing is obviously cold, when I pull on it, the spring inside tries to pull this thing back. See? And then of course, if that housing would heat up in like, let's say 1 or 2, 3 minutes, the spring would loosen and this whole thing would just naturally go open like this. All right. Let's so there's a right now I'm just doing haphazard work to do it quite fast. Okay, good. Excellent. Perfect. So we have a perfectly set choke. Since we are here, even though the bottom part is not attached yet, what we can do is take our vacuum pump and then set how far it's called choke pull-off, which means basically when the engine starts, this choke right here should open up just slightly, like something like this. Around according to specs, according to spec sheet, says choke gap setting should be in 73, 74, should be 1.5 millimeter, 74 California should be 2.5, and then later on 2.7 to 3 millimeters. Again, don't assume that the more modern the car, the so-called more advanced the settings are. What happens is the more modern the car, the more clean, the more of the rules of the Clean Air Act they have to deal with it. So they have to introduce a bunch of different settings with the carburetor to make it output enough of so-called good air or healthy air, whatever you want to call it. So in that sense, they try to rob the engine of the performance. So I would say probably if you want to bring your car part to so-called the best specs. 73, 74 is actually the one that's gonna give you the most power out of your engine. More or less, as you know very well, all those things are relative. So anyway, so now that we know that it's this, when I pull on our vacuum thing, okay, this should open by around 1.5 millimeter, which, so yeah, this is properly set. This is exactly what I want. It's supposed to be open 1.5. If I wanted to open it less or more, I would just take a small screwdriver and use the screw right here to screw it in and screw it out, so it opens less or more. Right now it's opening more or less the way we want it. Yeah, I would say 1.5 millimeter. Fantastic, great. All right, so all right, great. So this is set so far. Now we just have to add the bottom part. Let's see what else can we add. As we here right now, we can add the cover for our what's it called, fuel ball. This is just a purely mechanical cover. That, so if you are going to curious what the inside of the fuel ball is, if you look down here, you'll be able to see it. There's a float and everything. So as you can see, it's with those big holes and openings. It's open to the kind of our interaction, our curiosity, visual curiosity. So this goes here. Okay, now we should add this spring right here. Where is my spring? Is it here on this thing? Let's check something. So yeah, you see the more modern versions, they have this little spring washer, I mean plastic washer. So the spring right here moves up and down much more smoothly. So that's very nice. So let's just remove this guy from here. And I just flip it around to fish out. Hold on. There you go, there's a little tab. So there's a little tab. Put it in, flip it around. Okay. Okay. So now the another fun part starts. As you can see right now, this operates super smoothly. Look, if I press, like, you know, I can do it with no strength. However, when I apply a vacuum to this nipple right here, this whole thing is gonna pull this back, holding this wire, and then I won't be able to do what I was just doing. So you know, let's apply some of the car engine's vacuum. Let's go to, like, why is it? Okay, so what I can do, there's no way. I mean, it's super hard. I mean, incredible. How do we set this tension of the spring? We set it with this screw right here and this screw right here. All right, so the manual has certain procedure. For the one we're going after 73, 74, you have to create a weight of 112 plus and minus 2 grams weight. Don't worry about this is some stuff. And then what it is, what you can do is, like, take let's say you take a piece of paper like this, create a cone like this, put some kind of like let's see, again I'm doing it super fast for you so that you can see. Put some kind of screw at the very bottom, tape it, and then put it on some kind of weight that I like, that's precise enough that you can show you 112 grams, and fill it with screws, bolts, washers and whatnot till you get 112. And then when it's ready, you take this contraption and press it right here, right kind of like around at the very corner of this, yeah. And then when you press it, it should go just a little bit. Oh, let's remove the vacuum first of all. You should do it without the vacuum. So the vacuum is totally released. So nonsense, I can do this. And then when you press our homemade created weight, which I have it somewhere, and then you press it right here, it should just barely go down. And then you set the tension so it barely goes down. If you need to reset the tension, use this screw right here, but first you loosen this screw. So those two screws tighten or set the tension higher or lesser. I'm pretty sure I set the tension on this one, and I think, let's see, am I too lazy to find this weight? I have it somewhere. Maybe that should be like just a short video. But anyway, that's how we would set the tension, so this thing is properly tensioned. Just out of curiosity, if you want to know. That's 112 grams. That's for 73-74. For 74 California, 143 grams. And for 75-76, 170 grams. I wonder, let's see. So the higher, farther they go, because let's see, let's think it through for a second. So the lighter the weight, the more likely it is to press, and the heavier the weight, so that means the more you have to overcome. Okay, so in other words, they don't want you to drive driving on the secondaries that much. The higher you go, the more modern the age, because they require a bigger weight to overcome the spring tension. I guess they just want you basically to, drive carefully and conservatively. All right, so we have this set, and now it's time for our bottom part. Once again, our gasket. I used thicker-ish gasket on top and bottom. Now, before we go farther, let me just point something out with our base plate that I'm not super happy about. Let's see. So, in base plate, it's a rebuilt base plate. So in essence, as you can see, I ground down those screws. What happened, and then I rebushed this part and this part and this part and this part, so that they are basically perfectly, beautifully solid. Those parts, they do not waggle. They only wobble in this direction, but do not wobble in this direction or this direction. So that there is, so in other words, the shaft would kind of be doing this before, and right now it's perfectly smooth, so it just operates within up and down and maybe moves like this. The problem with this plate is, and maybe one day I'm gonna make a whole video of how to rebush this properly. The problem with this plate is that I suspect that the holes, the idle screws, not properly, they're of different sizes. So I suspect that there is somebody at some point over tightened one of those idle jets, went too far, and because of that, that's my suspicion. Just really quickly, if we can bear with me. Now would be the easiest way. I mean, just definitely. Again, this is not a scientific procedure whatsoever. But yeah, I can tell that this hole is much bigger than, well, not much bigger, but let's see. Yeah, you see, so this screw goes way farther. I mean, it's like a millimeter difference, so it goes 1 millimeter farther. So that means the opening of this opening is larger than this opening, which means this plate might not be too good for our use. Now, okay, can we still work with it? Yes, we can, but that means traditionally the way you would do it, you would put the screw it all the way in, and then screw out a few times, normally on the Solex 4A1 carburetor 4 times, and that would be your basic preset for idle jets, for idle speed. Because we get some funkiness going on here, then that means I would have to back out the hole with the bigger hole a few times, like maybe one more time. So instead of backing out both of those guys 4 times, I would have to back it out, let's say my one maybe 5 times and the other one 4, and because of that the calibration would not be precise. Now what do we do now then? So this is another plate that was not rebuilt. As you can see, those things were not ground down. Let's see, it's not super bad in secondaries. It's not fantastic with primaries. But the question is, should I go for it? Should I use this plate? Let's see. Let's see if any significant differences we can find. We got so many of those plates that let's see, this is a 0.35 and this is a 0.2. All right, so this one has some kind of stop, this one doesn't. This part seems to be very similar to both of those plates. This one doesn't have this part drilled, but that's okay. We don't want to deal with any of the vacuums. This, let's see, both of them have nicely plugged those 2 holes, which means nobody messed with those with the balance of those idle paths. Let's see, this is much smaller opening than this one, so that means it's going to provide smaller amount of vacuum for our choke. Let's see what else. The big difference is this has drilled passages here and here. This one doesn't. So as you can see, there's lots of things that well, first of all, we should check how good or how bad those idle guys see, they have some kind of funky idling. Let's have a look. I'm more convinced that our replacement is the correct one, and that's interesting. It's interesting. Come on. So this is the difference in those. Wait, they actually have a different, I can tell, different thread. Really? No, no, yeah, it's the same one. Okay, so let's see what would happen if we... Well, I tell you what, how about we just screw those guys in, so go to the max and see what happens on our replacement plate and see how far it comes out. So this is the max. Okay. I mean, again, this is just like a, so basically I'm measuring from this edge to the little opening right here. And yeah, so on both of those things, they come out the same depth. So the sucky part is because it's so deep, it'll be very hard to see that even you're screwing things. So it's not like if you're making some adjustments, this is not the sort of adjustments. So I suspect what it is, it's from a later carburetor where they will put the plastic covers on those things. So it's not ideal as far as we're concerned. So let me remove and replace those idle guys with the longer one. Yeah, the same. So now you get rid of, I mean, figure out how to, I'm gonna have to squirt some oil or something so that this guy, come on. Do I have some oil around? Not through the other room. All right, so that's gonna be our replacement plate. So as always, the only connection we care about is the C connection. The B and the A is going to be plugged. Let's see, let's just double check. Oh, I see. Check this out. So this, because this is an earlier plate, the one that kind of is slightly worn out as far as we're concerned, this later plate doesn't have the proper idle speed screw mounted. So that means I would have to replace this whole shaft with this guy right here. I mean, I could do this, and in that sense I could rebuild this. I do have some other plate. See, the problem with all the other plates I have, this guy right here unplugged, so I might have to kind of jump the proverbial, whatever the saying goes, and go ahead and rebuild this whole mechanism. Okay, well, let's finish putting it together with this stipulation that we might have to take it apart at some point. We'll take it apart at some point. So all those things lined up, and then we put our carburetor on the top right here. Okay. just threading something there. Okay, and then the last thing is we just need to attach those bolts right here. No, not this guy. Alright. Ooh, I'm getting tired. Alright, so the last thing is we're gonna add this guy right here. I think that there's spacers. Alright, you know what, that's a part one. Part two is gonna involve a few other elements. That's that. Alright, so we continue to rebuild this our carburetor on the bench. There's lots of little side parallel directions that I decided to take. That's fun, you know. And this one, I decided that we should actually do something at the bottom plate as well. Let me tell you why that is, and maybe as I'm disassembling. I mean, there's this screw right here, already one removed here. And then two more from the top that I have to remove, and then I'm going to tell you the reason why I decided to do something at the bottom plate. So originally we decided to use one of my two bottom plates that have those screws right here closed. So that means those so-called, they're called untouchable screws, well, untouchable by the manual. But I realized that this is not the best approach, and also the my other plate that has those things closed off. One of the idle screw was called holes was larger than the other, so because of that the one of the two idle screws could go deeper than the other, so because of that it's not exactly ideal situation. So let's talk about those untouchable screws for a second. I wonder if I should maybe grab schematics of it, or we're just gonna me talking about it is gonna be enough. Hold on, let's just give you a second. Let's just remove the bottom plate, and then we're gonna talk about it a little bit. Hold on, because that way sometimes it's better to see the reality of the world as opposed to a theory of what it might be or what it might not be. So something wrong with this screw. It shouldn't be so tight. Okay, I hope we didn't strip this plate. So we remove the, so let's move to the top thing aside. Okay. All right. So check this out. So on purpose I kept the gasket on so you can see. So as the air, so you have basically air kind of entering this part of the carburetor, and then here you have those plates right here. Now throttle plates, again, those are secondary plates, they're larger secondary plates. They are very tight against the metal. Not like 100% tight, but tight enough that you can call it precision fitment. Then you have this gasket above here, and you have those two openings in the gasket right here and right here with those little holes. And then you have the screw right here that right now is closed off, and that plug is closing off a tapered screw right here and right here. You see? And the idea is very simple, is that this screw controls how much air bypasses so in other words, from the outside entering the carburetor, how much air bypasses this plate and enters the bottom part of it. What is the function of this air? And in essence, well, there are two or at least two functions. So it could serve as some sort of air bypass. So in other words, when all the plates are closed, the engine still needs a little bit of air. Like let's say, for instance, like the choke is off, the plates are kind of closed, and so the only let's say air that you're getting into the engine is basically the air and fuel mixture coming through the idle screw, and then that sometimes might not be enough. So in other words, the engine might want a bit more air, and then you can feed that air via those those bypass ports, air bypass screws. Lots of carburetors have the air bypass screws. Some carburetors do not. For instance, the Weber carburetor, the 38, that's a very popular replacement for Mercedes, for Solex carburetors for the Mercedes. They don't have it, so you would have to take throttle plates and drill some kind of small hole openings to create this bypass, because by straight out factory often the Weber carburetor might not have pass on enough fuel by its internals. Again, maybe one of those days I'll make the whole video about the Weber carburetor, because I'm actually very familiar with that carburetor as well. So anyway, so here you have this bypass happening. Let me just remove this, since we already know we're dealing with those holes. And they tell you do not touch that. Now, why do they tell you do not touch those screws? Probably because after the carburetor is assembled in the factory, they put this carburetor on some kind of testing device, and that shows you that kind of probably pulls the air as some kind of pump, and then you have, again, this is my speculation, but I suspect that's exactly what takes place, or rather took place back in 70s, when the carburetor was being built. And you have two what's called pumps, like some kind of vacuum pumps, and then that shows you the difference in pressure between this intake hole and this intake hole, and then the factory worker at the bench basically adjusts those two screws, and then kind of to make them equal, so that there's the same amount of air coming through the two openings. Because remember, unlike this part of the carburetor that's very precise, this top part is very imprecise, so much so that obviously if I put some light under it, you can see plenty of openings, plenty of holes. This is not like precise manufacturing right here. So in that sense, the difference between this plate and this plate might be quite significant if you consider the tolerances, all the parts of the carburetor. So again, that factory worker adjusts those two screws and put the plugs there. Don't touch it. Of course, what we're doing right now, we disassembling the carburetor, maybe taking parts from different carburetors. So because of that, by definition, we are offsetting those screws. So they tell you do not touch those screws, and on one hand they are correct. On the other hand, you might see that that all the changes you make to the carburetor, including the one that, you know, with a little bit of warpage, the warpage might distort the top of the carburetor in such a way that maybe one part is slightly allows more air to pass by this opening than the other opening, and so on. So those so-called untouchable screws are much less of a, well, I don't want to say importance, because obviously they specify that do not touch them, but you know, they have a different meaning now. One of those days I might, out of kind of fun and curiosity, build a homemade pump to check the difference between those two chambers. But right now, for the sake of curiosity, I have right now I have 5 plates here in my workshop, the bottom plates, and 2 of those plates have the bottom plugs, so that's kind of like straight up from the factory, untouched. What's happening here? And then because of that, I can at least tell you, generally speaking, what the screw settings should be. So right away I can tell you. All right, so on this plate, let me just touch it with my finger. So yeah, basically you want the screw to go all the way in and barely protrude outside of this hole, and likewise on this side. Now this is with this plate. Let's just check this other plate, and just again, this is as unscientific as it gets. So yeah, I can tell you that this side right here, the screw goes all the way just barely protrudes, and here I can tell probably like a 0.5 millimeter it protrudes out. So in that sense, that hole was allowing lesser amount of air because the screw was screwed in farther than this one. So, and again, remember, this is straight from the factory. So the difference, obviously, you know, so in that sense, you know, to be safe, if you have a plate, just grab one of all the plates. Let's see. This is just a plate that the bolts, I mean, the closing thing was taken out, and then I can tell you right now they are not touching it. So I'm just gonna set this to where I'm supposed to set it. Let's see if I can. Oh, this is such an old plate that I might not be. Let me just grab a better plate. I barely moved the screws on this one. All right, so let's see what this one is. All right, so again, nothing. Oh, so it's literally like pretty much all the way in, huh? Yeah, I mean, both of them are all the way in. Now I'm bottoming out, and then I can barely touch those. So that means I wonder if there's some kind of difference, which I'm sure there could be some difference. In other words, let's see. That this screw that can't even go all the way out. Let me see, one more plate. I have 5 of them here. All right. Yeah. Yeah. So it seems based on those well, 2 plates that actually where I can touch the screw, and the one plate that, you know, just so rusted through that I can barely move the screw. That you kind of the bypass is more about the. Let me just pull out one screw out so we can see what that screw looks like. The bypass is about kind of like closing off the air vacuum. I mean air leak. I mean vacuum leak, and then one of them just being slightly more open than the other. And there you go. That's what the screw looks like for those bypass guys. Which I guess it's very similar. At least the thread wise, yeah. But you can see. Let me see if I can. So you see. Says and can you see that this is for the air bypass, and this is for your idling. So this is way more tapered, so that means it's way more precise. It gets like higher degree of precision. This is just simpler close off, close on, close it, on and off. All right. So yeah, that I guess it seems that the best scenario for you to basically screw those guys in, and as much as you can, and then kind of keep it like that, because there's no way you're gonna precisely set it, and it is what it is. So all right, so that's the conversation about those untouchable screws. Second conversation, let's just really talk about quickly, and I think mentioned it somehow, somewhere, at some point, maybe even during this video, but let me see if one of those. So this I grind off those what's called screws right here, because that's a sign for me that this carburetor was at some point rebuilt, or rather it was it was not at some point, it was rebuilt by me, where I removed the shaft and did the bushing replacement. So you basically drill it out and put what's called brass bushing. Let me just show you. Something like this, like a brush bushing inside, and that allows you to kind of so that the shaft is staying inside the bushing beautifully, so there's no air leaks. Now let's see. So this is our plate that we originally were going to use, because it has so-called untouched screws, but now we've learned a few things that that we're gonna kind of use a different plate. The question is, which plate should it be? This one is for a more modern carburetor, or more modern. They're all old, but this one has a fast idle screw, so that means for the throttle it controls how much the plate opens when the choke is in operation. This one doesn't have this element, because it's operates slightly differently. Let's see. This is kind of like that. Lots of pitting on this carburetor, but it's also more the older style, and the other two plates I have are also the older style. Oh, this one's a rebuilt plate as well. At least the front was rebuilt, because you can see I grind the thing. So that means this should work beautifully. And then let me see this one. No, it's probably only the front was rebuilt, because the secondaries, the shaft is actually what's called staying inside inside its bushing quite nicely. Let's see. So that means maybe we should use this as our rebuild plate. So let's see. First of all, so we closed off all the, they closed off, the untouchable screws are closed off. So let's take the other two plates, compare it, make sure that it's good. We're making sure that our C port, that's the most important, that's the only one, at least on the very basic setup we're going to be using, is going here to this hole. And then we need to make sure that our idle screw holes are correct. So let's see, we got this guy here. This one doesn't have any screws anymore, but I think this one has something here. So let's pull out this idle screw. when I started making this video, I had no idea there's going to be so many variables. I mean, I kind of knew that obviously that there are variables between all these carburetors, but I had no idea by putting one together it's going to be so much effort. Let's see if I lightly put this thing here. Again, this is, as you can see, this is as unscientific as it gets. Okay, that's actually not bad. I'm basically what I'm looking at, again, not scientific at all, but what happens by simply lightly putting the screws in, I'm trying to judge whether the openings are not bigger or smaller, and that means that those screws should rest more or less the same distance inside the opening, and they seem to be okay. So that means if I take them out and put them and screw them in correctly all the way in, hopefully they should. Oh, this one has some issues, huh? Okay. I'm just gonna make sure there's no gunk in there. There's something that's holding us. Oh, those are old parts, huh? Trying to save the old parts, but okay. Okay. All right, I think let's just do our law. Okay, so this thing stick out. Basically, I'm using this middle line that you might be barely visible for you. So this sticks out almost touching the line. This is still farther than it's supposed to be. I don't know what's going on with this guy. I would say they're kind of in a good enough zone, and since we're dealing with such rebuild, then we have to accept the good enough. All right, so what else? So we're gonna cap, not right now, but at some point we're gonna cap this A and B opening, because we don't care about those two. Let's see. We want to make this carburetor as simple as possible. This is the what's called for the choco canister pump vacuum. So it's already capped, so that's good, and that's about it. So I think all of this is working correctly. We got nice stop here. All right, I think this might be ready to be what's called put our carburetor. And again, the untouchable screws. It is what it is. Yeah. All right, so let's do it. Okay. That's that. Nope, wrong. That's okay. Okay. All right. Even though I've done this rebuild of carburetors many times, it is kind of exciting. You're like, yeah, success. I'm missing this screw somewhere. I need to find where I put it. That's the whole pleasure of working a bench, and then you discover that the bench is not as it's not right. Is it? No, it's not. It is. Okay. Right. That's right now, it's just generally speaking. And now we should finish putting that guy in here. All right, that's exciting. And then after this, we're gonna put the accelerator pump in. Okay, and then I'm missing a bushing here. There we go. Be much simpler to do if I remove this nut right here. Sometimes you're thinking it's gonna be simpler one way or the other, and you discover it otherwise. Then we just need to. There will be a nicer way to do it. Okay. Okay. So the good thing is we have this screw right here that let's see. Maybe I should. I'm just gonna replace this screw with this screw. It seems it's a nicer fit. And I like how stronger this spring is, and because it has a slotted thing that allows me, when I put it in, it allows me to count how many resolutions there is. Alright, so I just need to get like Phillips. Okay. So what is the function of this screw? When the choke is set, as it is right now, because you see right now the choke is set, then this, when I lift it up, you know, obviously it lifts because there's no spring, but this thing, there's a little bit of opening. Let me just make sure that you can see. There's a little bit of opening here, and this opening is controlled by how big the screw is. So I'm just gonna exaggerate this so that you can see this opening. I'm just gonna make sure that hold it back so that. So right now this is my opening, and then by screwing this screw in, as you can see, I'm increasing this opening. Now I'm going to like extremes, of course, and that controls at when the choke is set, what is our RPM. So in other words, the bigger the opening, the higher the RPM is. And then there's, in the manual, you can actually read what the RPM should be. So in our 1973 high idle should be, wow, that's high, to around 2500 RPM. So now, okay, let's put this into perspective. Let's say you do have RPM meter gauge attached to your car, and then you start the car and it's around 1500, 1800 RPM, and you're like, oh wow, something is wrong with the car. No, high idle RPM is measured at a hot engine. So that means, okay, it's counterintuitive. In other words, obviously choke is not applied during hot engine, so why are we measuring it? Well, the idea is that, let's say, the engine is hot, the choke is already off, and then you see like this, and then you set the choke by lifting this throttle level a little bit, and then pulling this arm right here up here, so the choke is set, and then that allows you. Now you measure the RPM, and now on the hot engine with the choke on, the RPM should be around 2500. So this is quite big. This is like, just kind of like open up the screw just a bit. That's a pretty extreme. I mean, I compress the spring almost totally. Something like this for the sake of discussion. All right, cool. What else do we have to do? We have to apply at the what's called the accelerator pump. Alright, so the accelerator pump requires this little plastic cap that can only go one way. See, it's an opening right here. And then it requires also a spring. It's very easy to put it because it's exact same size as this one. And then you put this dash pad or this rubber diaphragm. But before you do this, you just take this guy. I like sometimes I mean, this is already nice and smooth, but I like to kind of smooth out the surface a little bit with some kind of like fine what's called grid paper. And then the idea is that to insert this whole devices, use this down that goes into this opening right here behind it. So just put it like this. Okay, because with the camera right in front of my nose, it's very hard to see what I'm doing. There we go, and then goes like this. Then we put this guy in. All right, and then of course we take some screws. Okay, I can tell you right away, we forgot one thing, very important thing. But it is what it is when you rebuild something. It's a good thing I noticed it. It's this guy right here. I'm going to tell you what it does in a second. I'm missing one screw for this guy. Maybe one of those guys. This is a proper screw. Yeah, use this short one. Come on. Okay. You don't have to tighten it super tight because it's a rubber diaphragm, very soft rubber. Okay, and now what you can do is you can measure. So the idea is, let's see, did our paper, does it tell you? Beginning of injection, it's immediate. So that means that whatever you set, when you have this pump right here, there's this plunger resting against thing. The moment you press the throttle, see the movement of this pump should happen immediately. Now you wanna open up this bolt right here, this screw right here. See if it goes farther. So in other words, so that the pump is up extended as far as possible. So let's see. Okay, so now I'm opening up in such a way that there's actually a gap, which I'm sure, I don't think you can see, but in essence 0.5 millimeter gap. By screwing this thing, there's a gap between this level and the pump and then the plunger. So I'm kind of going back till it rests, yeah, right now. So there you go, perfect. Okay, so let's see what we forgot. We forgot those 2 long screws, and then the kind of important secondary bolt to prevent secondaries from opening up. Oh, this is exciting. Maybe next video we should take the camera out of the bench, bring it to the engine, so we can see all that work we've done. Okay, good. And then slow final, slow, tight, 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 and tight. Okay, and then the bottom part, tight and tight. All right, excellent. So let's see. So I have to basically add this little hook to to add it behind here. So in other words, I have to remove, let's see if I can do it, as you know, if you remember, it was such a pain in the ass to it's gonna be a pain in the ass again, I think. Maybe not. Maybe with a little finesse. Okay, so double check that our choke is okay. Okay, good. So let's just explain this hook a little bit. So you have this bolt right here that connects to your secondaries, and you have this hook right here that's basically gravity closing and opening, and in theory it should catch, this hook should catch on this thing. The reason why it's not doing right now is because we added a little extra thickness of the bottom and top gasket. So that means right now what I should do is I should, let's see if they have any small tools. I don't want to be like a guy, an asshole guy, but in essence I have to bend. Now again, normally you would not do it, you just do it in a case like mine. What I could do is bend this little tab right here and bend it slightly down so that this hook can catch on. And it's a kind of pretty clever thing. So when the hook is, let me just maybe fix it. Let me see if I have something. This is wrong too. I already have a correct tool to do it, but not yet. This is not a good tool either. You're gonna make fun of me for using such tools for. Well, you know, let's I'm gonna do it off camera because it's just getting ridiculous. Anyway, so the idea is as follows: is that when this hook is down, your secondaries cannot open. So in other words, and the hook is down only when the choke is engaged. So the idea is that engineers decided that we don't want you to be pulling on the and doing. Let's say I'm gonna throw it upside down so you can see it. We don't want you to be flooring the engine when it's still cold. So so they have this hook right here that basically says that, you know, when the engine is cold, you can only operate on your primaries, which is, you know, those two right here. And only when the engine warms up, the hook comes off, and then the secondaries kick in. So I should remember to do this before the thing is being put into the operation. And guys, I guess this is it. So let's go. Let's figure out what we've done. We double checked that all the internal main jets are correct to spec to the year we're going after. We confirmed that our idle what's called idle air jets are correct based on the specs we're going after. We confirmed that the internal float is set correctly. We confirmed that our choke kind of closes correctly here and closes correctly here, and that when we apply vacuum to it, it opens up what it's supposed to open. We confirmed that this what's called accelerator pump is engaging on the right when the moment we press the what's called the throttle. We at least spoke about how to set this dashboard with the correct weight, which I'm not sure we necessarily did because I can tell that this is very loose. Then Oh, we have to apply a few things. Hold on. And then we have to apply this idle throttle stop. Should probably like break down this video at some point and make only videos about specific components that we're trying to fix. But then for the aficionados, I'm gonna put up the long one as well. Okay. Easier to do. Well, that's not so bad. If you can see enough. Okay. And so then the rest of the what's called settings we would have to do on the actual working engine. Okay. The last thing we need to attach the what's called the spring, which is where the hell is my spring? Should it be here somewhere? Problem of my life, putting parts together seemingly in place but not really. It's not exactly the best. There's gotta be a nicer way to do this spring. I'm like now going into aesthetics. Alright, cool. So the spring is pulling back this level. As you can see, there is an opening here and here. The reason why we do not go, why don't we go so far? Just double check that everything is. Let's see what happens if we take the carburetor off the choke. Okay. Alright. So right now, when I remove the choke. Just get you some more light here. This plunger is holding on to, and then if I apply some vacuum to this plunger, this bolt should retreat back. All right. So now nothing is holding our. Okay. Now we are this. So now there's okay. So at 15 atmospheres, there's all an inch. Millimeter and a half here, and then on the engine, I would try to figure out how our RPM. Let's see what our RPM should be based on our paper. So when this plunger goes back, based on the vacuum of the car, and then the plunger here, this bolt doesn't touch this thing, and then this whole throttle lifts only on this, stays on this screw. In park, your RPM should be, let's call it, let's say 800, 900 RPM, and when you go to what's called 2D, it should be around, well, according to the specs, in gear it should be 700. Yeah, I like it personally a bit higher, 700, 800. So it's up to you and on your engine. There's a whole video I have about how to set this thing, so I want to make this video even longer than necessary. Let's see, and I guess that's it. Let me just make sure that just show you the kind of like the most basic connection. So this plunger, I mean this throttle governor goes to your C connection, which is somewhere here. Your A and B should be capped, and then let's see if I can get those. Well, I don't know where I have a longer vacuum. This should go here. Again, it's gonna be too short, but just for the purposes of showing you. And this right here nipple should go to this nipple right here, with of course proper length of the vacuum hose. And then lastly, this aside, and then lastly, since if you remember we screwed those guys in all the way in, you should unscrew those things around 4 times. I'll just do it right now so you can see the effect of it. So half, 1, 1.5, 2, 2.5, 3, 3.5, 4. As I can tell, it's basically it's barely the screw is just barely kind of inside the hole. All right, so half, 1, 1.5, 2, 2.5, 3, 3.5, 4. Yep, and again same setting here and here. So this is your carburetor is ready for to put on the engine. Of course, we should probably like put those guys here, which are the interrupter for the flow of fuel. You could kind of cap those things. Just make sure you don't put the bolt too deeply that there's no flow of fuel internally. But if you want, this is the sort of piece of gear that barely ever goes. Those interrupters. There's a proper name for those interrupters, which of course now I forgot. This is you know, one of those things that barely ever go bad. So you should not worry too much about this not so-called working correct. Of course you can test it. And that's it. Here's our rebuilt carburetor. Ouch. That's ready to be put on the engine and hopefully ready to rock and roll. Cool. Yeah, that was well, both long, exciting and painful rebuild. That also shows you how what complexities of this carburetor, as in how things might not appear as simple as they might be. That said, do not give up. Keep on going forward, and hopefully you can save this carburetor from swapping to Weber.